methane comes out, is this a seeping or is this like a blasting out? That has not been clear. And the second thing is this, and I'd be interested in whoever would like to comment on this. There's been a lot written and talked about for years and years about whether or not there's life on Mars. And when there was a tiny possible ripple of liquid going down in a crater, there was a lot of discussion then about it. It just seems to me that in some ways, well, it would be important, I think, for people to get a sense of how this ranks in that. Is this a step forward in terms of determining whether or not there is life on Mars that is similar to anything we've done before, or is this entirely new? Is this the kind of breakthrough that people have been looking for?
How do you want to deal with this?
I'm interested in your opinion.
Okay. Now, he didn't say what if, so I'm going to. I'll give you my thoughts that are based on what we know and what we reasonably can posit as a hypothesis to be tested. This is not speculative. It's just where might this lead us. The first question aspect was do we know whether the methane is released slowly and gradually versus explosively? The answer is no, we don't know. It's interesting to consider, though, what would happen if you had methane building up under the permafrost in a sealed environment over a Mars year, which is sealed from the escape to the atmosphere by an ice face on the scarp, essentially sealing ice pores or fractures in the rock. The pressure would likely build up substantially, and as the ice the plugs in the pores were sublimated in early spring and late spring and early summer, you might then think that there could be a sudden release of the pressure into the atmosphere. And then a lot depends on what the nature of the material is through which it's escaping. If it's merely fractured rock but still fairly intact, you're probably going to get just little jets of gas coming out in tiny cracks. But if it's less well coordinated, you might actually blow off a little patch of the material at the surface, and it could then come down the side of the scarp face and have a little trail of material. And on the other hand, we don't know that these are solitary vents. It could be that the methane is being released from a distributed area of the surface, and you could imagine that if it's on the one hand biology, it could be that you're warming a large surface. I mean large by many thousands of square kilometers, so extending over a zone of perhaps even 800 kilometers in diameter. And you could gradually activate biomes there that could release methane from the whole general surface area. In that case, you'd really never even be able to sense that as a human being. I mean, it would just be a little extra gas that we can see spectroscopically and so on, but you wouldn't sense it individually. So those are key questions, and when we actually get to the point where we can define the source regions more accurately, I will comment that we have been granted time at the European Southern Observatory in August to use one of their telescopes with adaptive optics, which provides very high angular resolution and a very high resolution infrared spectrometer that will assist us in identifying and further constraining the size of these release zones, if we're fortunate. So that's how we can assess this question. But ultimately, it will require some kind of active high-resolution imaging from orbit. We have some of that already, but unfortunately, we don't have global capability. The other part of your question, first let me ask whether others might wish to comment on this.
I was going to comment on the second part, and that reminds me of a quote that you can tell the genius of a scientist by how long it takes for their theory to be proven wrong. And so Newton lasted a very long time until Einstein came along. So the point is, we don't know until we have a chance to work on this and come up with theories that hold water to explain this very important measurement.
But as I mentioned a few minutes ago, even if we say we really have no way of knowing if this is geological or biological methane production, the fact that it is now expressed in significant quantities at the surface allows us to turn around and say it's much easier to make a living consuming methane than to try to make a living producing methane by carbonate reduction. So now we have a reason to go in there and say, gosh, if there's methane coming out in focused areas and there is life, then the life should be where the resource is, and it gives us a bullseye to go after. It says, let's come in here and take another look. And in this case, we wouldn't be looking for the methane producer. We'd be going and saying, what about a methane consumer? And given that the surface of Mars has an enormous amount of sulfate, then the pathway for sulfate reduction coupled to methane oxidation starts to look like a very attractive one. And we know on Earth that metabolism is one of the most ancient ones on Earth, and is one that even if there was only a rather primitive form of life, that would be a good one to take advantage of the collective chemistry that we see on this planet.
Okay, we have a number of media on the line, but I'm going to let's keep this down to an hour. Our scientists here and the participants will be available for follow-ups. But we will take one more call from the line, the New York Times. Kenneth Chang?
Yes, can you hear me?
Yes.
Okay, so my question is, this data is presenting a one-time emission of methane. People have mentioned several times that it's seasonal. Since you have data for 3 Martian years, can you definitively say it's a seasonal release?
We aren't at liberty to discuss the measurements made at other seasons at the moment. You may expect to hear more about that in the near future.
Yeah, what we have done now, we have presented here is the Northern Summer 2003. You have to understand it's 7 years of data. And now we have preparing the maps for other seasons to see how they present in other seasons. That will be future work, and because of the huge volume of data. Definitely, we do know methane is in other seasons, and we are preparing a comparison also how these measurements compare with water. So it's going to come soon. We are working heavily in this data set right now.
Okay, let's go ahead and wrap this up. Again, our scientists will be available for follow-up interviews. A few programming notes. There's been talk about the Mars Science Lab. There is a Rename the Mars Science Lab student contest. NASA, in partnership with Disney Pixar's WALL-E. For the folks out there, particularly our students and educators, the deadline for that contest to come to a close is approaching, January 25th. Go to www.nasa.gov for the guidelines. Rename the Mars Science Lab. For our television folks, we will have video B-roll to complement today's science update. 2009 is going to be another year where science never sleeps. Thanks for joining us. Have a great afternoon, and everyone have a great year. Thank you.
Hi. Real fun. Leonard